My name is Professor Melanie Britton, and I'm an academic in the School of Chemistry at the University of Birmingham in the United Kingdom. So I use magnetic resonance imaging, a technique that's more commonly used in hospitals to look at people's brains, but I use it to look at chemical systems. I'm fascinated with understanding how many systems behave at a molecular level, and those systems could be anything from looking at a consumer product to looking at a battery, or even just looking at some fundamental science such as pattern formation. I think the beauty of NMR and MRI is that it's non-invasive, and so you're able to probe things without destroying them. The other wonderful thing is that you can penetrate samples that you can't look through, you can't see, so we would say they're optically opaque. There's a lot of interest in developing better batteries. I mean, we are moving towards carbon neutral, and in order for us to do that, we have to move away from the classical fuel types such as oil and coal. And so batteries offer a really great opportunity for us to store energy that might be created more sustainably. And then it allows us to transport that energy. But we are currently heavily reliant on lithium-ion batteries. And as wonderful as they are, there are limited resources associated with lithium batteries. So lithium is a depleting resource, as is cobalt and nickel, which are also found in lithium batteries. So what I'm really interested in is developing new battery chemistries, one that don't rely on lithium. And so I've done some work using MRI to study sodium-ion batteries, which offer some really exciting advantages over lithium batteries. I also am really interested in moving into more exotic batteries that are maybe even further away from commercialization, such as zinc or aluminium batteries. There's a variety of challenges that current batteries are facing right now. I think the depletion of resources is a major one. We cannot simply be digging out of the earth all of the elements that we need for those materials. The other problem is that there's increasing electrical waste and there's increasing battery waste. If we're going to move to having more electric cars, they will have a finite lifetime, and then we cannot simply get rid of those batteries. So we have to be able to recycle them. So in fact, research that we do in my laboratory is looking at not only making more sustainable batteries, but we're also interested in actually making more sustainable recycling processes as well. The new areas I think that we're providing new insight into new batteries is helping to develop sodium-ion batteries. And while we know a lot about how lithium-ion batteries work, for sodium-ion batteries we cannot use all of the same materials. So the anodes and then cathodes need to be different, but also we need to have new electrolytes. And so using NMR spectroscopy and MRI, we have the opportunity to do that. So we published some work in the last few years in Nature Communications where we actually had a look at a sodium-ion battery working inside the magnet in what we call inoperando conditions. This is under working conditions. And so we were able to see things that are simply not possible to see with any other technique. We were able to visualize dendrite formation, but something that we observed that nobody had ever actually shown experimentally before is that sodium metal can actually form very early on in charge cycling. And so that's the beauty of NMR, is that you're able to reveal things under working conditions that you simply cannot measure using an ex situ measurement, where you have to perform the cycling, then you disassemble the battery, and then you look at the material separately. So we are hoping to benefit the public by making new battery chemistries commercial. So we need to understand how to make sodium-ion batteries better, and if we can do that, then that offers batteries to become cheaper, more sustainable, and there's also other benefits potentially from making safer batteries. I think this is a very important thing. So we have been working in a battery technology that is quite close to being sort of widely commercialized. But what I'm really excited about is actually moving into new battery chemistries. If you start to look at zinc or aluminium batteries, these are much more abundant metals, and they also have more than one electron associated with each metal ion. And so they offer much higher energy and power densities. So zinc and aluminium batteries are for the future. They are, I think, over 10 years away. And so little is known about the sorts of materials that we need, the processes that happen inside those batteries. And so I think we really need to have the characterization techniques that NMR and MRI offer to be able to make those exciting new battery chemistries a reality.